In this segment, we're going to talk about differentiation of continuous functions, what kind of prior knowledge you need to have so that you can conduct numerical differentiation. So if you look at this particular figure here, this is a function f of x being plotted as a function of x. And let's suppose we call this distance here between p and q on the x-axis to be delta x. So what you are basically going to do is that, let's suppose I want to draw a secant line from point to point Q right here. So I'm interested in finding out what the value of the derivative of the function is at point P. And what I will do is I will draw a secant line just to approximate it. So that's how we learned in your differentiation class. So it will be this divided by delta x. And so that's the slope of the of the secant line. So because that's the rise and that's the run. And what we learned in our numerical differentiation class was that as q approaches p, then delta x is approaching 0, and that becomes the exact definition of the derivative of the function. That as q approaches p, the secant line becomes the tangent line at p. So that's how we define our first derivative of a continuous function. Let's go and review through an example. So let's suppose I am being asked that, hey, can you find out the first derivative of the function f prime of x for this particular function? You want to find f prime of 3. And we're also asked to find f prime of 3 if you draw a secant line with delta x equal to 0.5. So this is just to bring everything together so that you have some recall of what you learned in your numerical differentiation class. So let's go and get started. So if you look at this, that you have f of x equal to 7x squared, and if I want to find f prime of x, then we know that 7 times the derivative of x squared is 2 times x, and that gives us 14x. And if I want to find the value of f prime of 3, that becomes 14 times 3, and that becomes 42. So that's the answer to the first one. What I'm going to do is I'm also going to show you how to derive the value of f prime of x to be 14x if we start from the very definition. It's just to recall, and also this is going to very much help you to figure out, hey, what it means to numerically find the derivative of a function. So if you remember, we said that f prime of x is equal to the limit of delta x approaching 0, f of x plus delta x minus f of x divided by delta x, right? So if our f of x is equal to 7x squared, what we're going to do is we're going to say, hey, f prime of x is limit of delta x approaching 0. And we're going to write down the function at x plus delta x, which will be this, right? We'll write the function at x, which is 7x squared, and divided by delta x. And now it's all about simplifying it. So we'll use the a plus b whole squared formula here. We get 7, we get x squared plus delta x whole squared plus 2x delta x minus 7x squared divided by delta x. And if we simplify it some further, we get this. And from here, you can see the 7x squared cancels with this one. So if I take the limit of delta x approaching 0 here, this is 7 delta x squared divided by delta x. That's 7 times delta x then. This is 14x delta x divided by delta x. That gives 14x. And as you can see that as delta x approaches 0, this quantity is going to approach 0, and this quantity is going to approach 14x. And that's how we get the 14x from. And that's how we got that the f prime of 3 is 14 times 3, which is 42. So this is solving for the value of the derivative of the function from the basics. So you can see that how this formula works. It's not magic that we find f prime of x to be 14x here. So in part B, what we're asked to do is to figure out that, hey, if we are trying to find the value of the derivative of the function by seeing what is the slope of the secant line, this is x equal to 3, so not drawn to scale here. Let's suppose this is x equal to 3.5. So we are looking at a run of 0.5, that's delta x. And then you can see the rise will be this amount right here. That will be the value of the function. This is the value of the function f of x plus delta x, and this is the value of the function x. So the difference will be, of course, f of x plus delta x minus f of x. So if you look at the secant line, the derivative of the function will be approximately equal to f of x plus delta x minus f of x divided by delta x, rise over run, where this is the slope of the secant line. Now we know that x is 3, delta x is 0.5. We subtract 3, function at 3 divided by delta x, which is 0.5. So it is the difference between the function at 3.5 and 3 divided by 0.5, which is going to give us the slope of this secant line right here. So we're trying to find the slope of this secant line. So we get 7 times 3.5 square minus 7 times 3 square divided by 0.5, which in fact turns out to be 45.5 once you do the calculations. And this one is very close to 42, which is the exact value. And you can see that if you decrease the value of delta x, it is also going to improve the value of the derivative of the function. So I should have called this to be f prime of 3 here. And that's what we're getting. So this f prime of 3 is not the exact derivative of the function. It is an approximate one, but it is the slope of this secant line. And that is the end of this segment.